Ready to take your engineering ideas from concept to prototype in record time? Imagine transforming your wildest mechanical concepts into real, working prototypes faster than ever before. In today's world, the pace of innovation is accelerating, and engineers are expected to deliver smarter, more efficient designs in less time. But what if you could harness the power of artificial intelligence to supercharge your workflow, eliminate tedious guesswork, and focus on what really matters: creativity and problem solving? That's exactly what we're diving into today. Whether you're a student, a professional engineer, or a hobbyist tinkering in your garage, this guide will show you how to leverage AI tools to streamline every step of the mechanical design process. So, grab your notepad, fire up your favorite CAD software, and let's embark on a journey that will change the way you design forever. Let's see how AI makes mechanical design way easier. With the right AI-powered tools, you can automate repetitive tasks, generate innovative design alternatives, and even predict potential issues before they become costly mistakes. No more staring at a blank screen, wondering where to start. Instead, you'll have a digital assistant by your side, ready to help you brainstorm, optimize, and validate your ideas in real time. From the initial concept to the final prototype, AI is revolutionizing the way engineers work, making the entire process more intuitive, efficient, and enjoyable. Start with your goal. Before you even open your design software, take a moment to clearly define what you want to achieve. Are you aiming to create a lightweight component for an electric vehicle, a durable valve for industrial machinery, or a robotic arm joint that can handle precise movements? Write down your objectives, and don't be afraid to dream big. The clearer your goal, the more effectively AI can help you reach it. Think about the problem you're solving, the environment your part will operate in, and any constraints you need to consider. This foundational step sets the stage for everything that follows. What are you designing? A gear, a valve, maybe a robotic arm joint. Each project comes with its own unique set of challenges and requirements. For example, designing a gear might require you to focus on torque transmission and wear resistance, while a robotic arm joint could demand high precision and lightweight materials. By identifying the specific type of component you're working on, you can tailor your approach and select the most appropriate AI tools and techniques. Remember, the more specific you are about your design intent, the better the AI can assist you in generating optimal solutions. Write down every requirement, things like load, torque, speed, and which materials you need. Don't forget to consider factors like operating temperature, environmental conditions, and safety standards. The more detailed your requirements, the more accurate and relevant the AI-generated designs will be. For instance, if your part needs to withstand high temperatures or corrosive environments, specify those conditions up front. If weight is a critical factor, make sure to include maximum allowable mass. This step is all about translating your vision into concrete, actionable parameters that the AI can work with. Next, pick your AI tool. The world of AI-powered engineering software is vast and constantly evolving. Depending on your project, you might choose a tool that specializes in generative design, topology optimization, simulation, or even natural language processing for brainstorming ideas. Take some time to research the options available, read reviews, and experiment with trial versions. Many platforms offer cloud-based solutions, allowing you to access powerful AI algorithms without the need for expensive hardware. The right tool can make all the difference, so choose one that aligns with your workflow and project goals. For structural design, Autodesk Fusion 360's generative design is a solid choice. This powerful tool uses AI to explore thousands of design possibilities based on your input parameters, such as material type, load conditions, and manufacturing methods. It can quickly generate lightweight, high-strength structures that would be nearly impossible to design manually. Plus, it provides visual feedback, allowing you to see how different design choices impact performance and manufacturability. If you're looking to push the boundaries of what's possible, generative design is a game-changer. Need to optimize lattice structures? nTopology's got your back. This software excels at creating complex, lightweight lattice geometries that maximize strength while minimizing material usage. With nTopology, you can easily define custom lattice patterns, adjust cell sizes, and fine-tune structural properties to meet your specific requirements. The AI algorithms analyze your design goals and automatically generate optimized lattice structures, saving you hours of manual modeling. Whether you're working on aerospace components, medical implants, or consumer products, nTopology empowers you to create innovative, high-performance designs with ease. Want AI help with stress tests or brainstorming? Check out solutions like SolidWorks with AI plugins, Ansys Discovery Live, or even ChatGPT. These tools can assist you in running real-time simulations, analyzing stress distribution, and identifying potential failure points before you even build a prototype. Some platforms even integrate with AI chatbots, allowing you to ask questions, generate ideas, and troubleshoot problems using natural language. Imagine having a virtual engineering mentor available 24/7, ready to guide you through complex challenges and suggest creative solutions. The possibilities are endless when you combine human ingenuity with AI-powered insights. Now, enter your constraints: fixed points, load values, material types, and weight limits. Constraints are the rules that define the boundaries of your design space. By specifying these parameters, you tell the AI what's possible and what's off-limits. For example, you might set a maximum deflection for a beam, a minimum safety factor for a bracket, or a specific material for a housing. The more precise your constraints, the more targeted and effective the AI-generated solutions will be. Don't be afraid to iterate and refine your constraints as you learn more about your design's performance. The AI will crunch this data and instantly suggest multiple smart designs based on your specs. Instead of spending days or weeks manually modeling different configurations, you'll receive a curated list of optimized options in minutes. Each design is tailored to your requirements, taking into account factors like strength, weight, cost, and manufacturability. You can explore unconventional geometries, innovative material combinations, and novel structural concepts that you might never have considered on your own. This is where the magic of AI truly shines, unlocking new possibilities and accelerating the path from idea to reality. Compare the options side by side. Take your time to evaluate each design, considering factors like performance, manufacturability, and aesthetics. Use the software's built-in analysis tools to visualize stress distribution, deformation, and other key metrics. Don't just rely on numbers. Trust your engineering intuition and experience. Sometimes, the best solution isn't the one with the highest efficiency, but the one that strikes the right balance between competing priorities. Involve your team, gather feedback, and make informed decisions based on a holistic understanding of your project's needs. Analyze each for shape, strength, and efficiency. Dive deep into the details. Examine how each design handles loads, resists deformation, and meets your performance targets. Use simulation tools to test different scenarios, such as varying load conditions, impact forces, or thermal stresses. Look for potential weak points, areas of excessive material usage, or opportunities for further optimization. Remember, the goal is not just to create a functional part, but to achieve the best possible balance of performance, cost, and manufacturability. AI gives you the power to iterate rapidly, so don't hesitate to explore multiple options and refine your designs until you're satisfied. Pick the one that checks all your boxes. Once you've identified the design that best meets your requirements, it's time to move forward with confidence. Document your decision-making process, noting the key factors that influenced your choice. This will help you justify your design to stakeholders and ensure that everyone is aligned on the project's goals. Remember, the best design is the one that delivers the right combination of performance, reliability, and cost-effectiveness for your specific application. Before you commit, run simulations right in the software: stress analysis, motion tests, or thermal checks. These simulations allow you to validate your design under real-world conditions, identify potential failure modes, and optimize performance before you invest in physical prototypes. Use the results to fine-tune your design, making adjustments to geometry, material selection, or manufacturing processes as needed. The ability to iterate quickly and test multiple scenarios is one of the biggest advantages of AI-powered design tools. Embrace the process, and don't be afraid to experiment with different approaches. The AI highlights weak spots and suggests tweaks instantly. This real-time feedback is invaluable, allowing you to address issues before they become costly problems. Whether it's reinforcing a thin section, adjusting a fillet radius, or optimizing a load path, the AI provides actionable recommendations that help you improve your design with minimal effort. Take advantage of these insights to create more robust, reliable, and efficient components. Remember, every tweak brings you one step closer to the perfect solution. Last step, refine your design based on those results, then export the file for 3D printing, CNC machining, or prototyping. This is where your digital creation becomes a physical reality. Choose the most appropriate manufacturing method for your project, considering factors like cost, lead time, and material properties. Prepare your files, double-check your settings, and communicate with your manufacturing partners to ensure a smooth transition from design to production. Don't forget to document your process, capturing lessons learned and best practices for future projects. The journey doesn't end here. Use feedback from testing and real-world use to further refine and improve your designs over time. AI just made mechanical design faster, smarter, and way more fun. By embracing these powerful tools, you're not only saving time and reducing costs, but also unlocking new levels of creativity and innovation. The future of engineering is here, and it's powered by artificial intelligence. So, whether you're designing the next breakthrough product or simply looking to improve your workflow, remember that AI is your ally on the path to success. Keep exploring, keep learning, and never stop pushing the boundaries of what's possible. Happy designing!